Readings in astrology. 1, 2, 3, 4.
Welcome again to the Southwest Climate Podcast. As always, my good friend, Mike Crimmins. Mike, how you doing?
Hey Zach, how you doing? Happy spring?
Is
Are you
it
feeling
spring?
it?
It's
Oh
spring.
yeah, man. I think it's like astronomically, astrologically,
It's definitely astrological.
meteorologically. Okay, yeah. I think it's all of those.
In one of the classes that I taught, a climate class, I would always unwittingly switch astronomical and astrological until finally one of the students came up like mid semester and was like, you say astrological a lot. And I'm like, do I?
So I 100% I've done that in public talks.
And
And
I'm like, that's kind of the opposite of what I'm trying to convey here, talking about like glacial and interglacial cycles as being driven by the astrological chart.
Hey man, what's your sign, man? That's so funny.
Yeah, fortunately, in their reviews of me, no one actually mentioned that, so I'm not even sure anybody's
Uh,
paying attention.
Well, there you go. You could have you're planting little Easter eggs there to for them to find in your presentations.
Yeah, I can be loose with my words. Hopefully, I won't switch El Nino and La Nina, which I periodically do too. Anyway,
Yeah,
so
yeah,
we got a lot to talk about. We are
absolutely.
basically a month removed from our last podcast, where you did wish me like a happy new year at the end of February. So
Oh, was it? Oh, well,
yeah, I do
I think
remember
I'll
that.
okay. I'm over that now. Like I haven't done that in a couple weeks. So
All right. So I think what is nice about this moment is we're sort of looking back at the winter now. Much of the winter has passed. Although I will say this, by the time this pod actually drops, we'll probably have gotten a little bit more rain and snow in the mountains. There's something on the horizon. So we're coming at you on Friday, March 29th. Expectation is for rain across the West on over the weekend. So it's not quite done yet, but I think it's a fair moment to reflect on the winter in addition to, the last 30 days or so, get people caught up to speed on that. We've got so we'll do that. We'll take a look at the snowpack conditions. This represents we're close to the peak of the snowpack, and that is the pivotal moment where streamflow projections become pretty important for our major rivers here in the Southwest. We'll unpack a little bit the ENSO, the El Nino event, which was a strong event, one of the strongest on record, how that ENSO played out in terms of our winter weather, sort of deconstruct, maybe ask the question, Mike, what was ENSO like and what was El Nino like and what was not El Nino like about this winter. And then end, looking toward the next couple months. I'm curious, Mike, what are some of the things that that you're eyeing for the spring? So how does that sound?
sounds good, man. Let's do this.
All right. Okay, so big picture here. Looking across the West, we're coming at the end of the month here, and we didn't do this strategically because had we waited a couple days, a lot of the data for March would have come in, and
Right.
we would have these nice summary statistics like Arizona was, the 15th wettest on record. We don't have that, so I'm eyeballing a lot of the statistics here and trying to piece together. And so my qualitative assessment of this year's winter is that for I'd say 80% of the West, it was an above average rainfall and snowfall winter, that you have to go up to sort of northern Idaho, sort of mid-central Washington, northwestern Montana for there to be sort of larger regional patches of below average rain. We had it here a little bit in the Southwest and sort of the northwest part of Arizona and maybe sort of central west part as well, and then moving more towards eastern New Mexico. But that picture is quite a wet, I would say wet winter. The winter kind of kicked in January, sort of a late start to the precipitation and snowpack. There was a lot of rainfall, and particularly in the Sierras, a lot of snowpack to make up in January. And one of the bigger winter stories was these atmospheric rivers that sort of bombarded the West Coast, and they delivered really copious rainfall to the parts of the coast, but the interior, actually, the Sierras, never actually caught up completely in terms of snowpack to average conditions. So despite those atmospheric rivers, the snowpack there was, and we'll get into this, snowpack there was slightly below average. Let me just
even with that, I was going to say, Zack, even with that epic like 10-footer snow event that
it's true. So I'll dive into that a little bit more.
Okay. Yeah, I'm interested to hear more about that. Yeah.
But let me just go quickly around the Southwest now, looking at Tucson, Phoenix, Flagstaff, Albuquerque, and Las Cruces, and give people an update there on the rainfall. I would also say, and we don't often talk about this, but it was also an above average temperature situation across the West. That's a very normal picture, though. Okay, so Tucson International Airport right now, end of March, we're about 6 inches of rain, where the average in a normal year is 5. So we're, what is that? 125% of average, 120% of average, thereabouts. We still have maybe, again, I said this in the beginning, we still have, a storm on the horizon, and somewhere in the order of 1/4 of an inch normally falls between now and the end of, let's say, the start of the monsoon season, right? So a good picture in Tucson, one of the better pictures in terms of rainfall across the Southwest. Phoenix is right at about average. Again, there's spatial variability around the metropolitan area, but it's right at about average. So for this moment, if it didn't receive any more rain, it would be below average for up until the monsoon season starts. But right now it's average. Flagstaff is just a little bit below average. It's received about 10.5 inches of rain. Again, the storm will probably boost it close to average. Albuquerque, slightly, no, it's about, we'll just call it average. And then Las Cruces is where the sort of below average picture comes into play, this sort of southern and southeastern New Mexico. And so Las Cruces has received close to 2 inches of rain, and sort of its average is more like 2.5 inches. So I guess the question for you, Mike, again, there's been more wet areas than dry areas, but there has been a few dry areas. I didn't mention Kingman, but the Kingman area has been dry, and then the southern and southwestern or southeastern New Mexico. And I'm just curious, the southeastern New Mexico, any thoughts on why that area sort of bubbles up as a drier than average region?
Yeah, I think it has to do with if you look across the whole Southwest, and it was just what you mapped out here, kind of visually, mentally, is that there's basically average to above average precipitation that cuts a stripe across the Southwest from Southwest Arizona. There's some stations down there that they don't get a lot of rain that have actually done really quite well this winter. And so Southwest Arizona cuts through central Arizona, and then up into northern New Mexico. And just as you pointed out too, it's then go far northwest Arizona. It has rained, and especially it has the precip picked up since January 1st. It didn't really nothing actually happened in December, November, December, and it wasn't until kind of later part of the season that stuff picked up. And then, like you said, the southeast part of New Mexico has kind of fallen off as well. And I think it has to do with the way that the precip's events stacked up over time. Is that several of them had these tracks of, as often the case as these low pressures come through, is they'll pull up moisture ahead of them, track storms from the southwest to the northeast, and they were just quite consistent in the way that some of the larger events mapped out across the southwest. And it's a little bit unusual when we think about an El Nino winter to have kind of these gradients the way that they've mapped out across the southwest.
Yeah, so I mean, you can almost see like the pattern of this of the storms, and its movement from southwest. So coming up from Tucson, moving from San Diego, Tucson, up through the Four Corners area, and actually even through Denver. But like that's almost misleading, right? Because like the Denver, sort of as you go further north, like it's a different kind of. The storms there might be coming down from Canada and that. So it's maybe a false. I can't like draw the position or the flow of the storms just by looking at this this map. But Denver, the high country of Colorado, has been one of the snowier and wetter areas in the West, much like sort of the high country of Arizona and New Mexico, and even the southern parts of south of Tucson and south.
Yeah, I mean the storm events that have happened in Denver on the kind of the east side of the Rockies, those will often have really different storm events, and we can have a lot of low pressure systems move through the southwest completely dry, just make a lot of wind, and then pick up some Gulf of Mexico moisture and then wrap them around into some pretty epic late season storms in that part of the country. And so the dynamics change a little bit differently. And so, these low pressure systems we've had numerous ones of them, and they've threaded up some impressive subtropical moisture, as you'd see during an El Nino year. And some of them have actually been real long ribbons that you'd consider kind of atmospheric rivers. And then you can get pretty narrow bands of precipitation that will, trace out these kind of wet patterns that we're seeing across Arizona and New Mexico.
I mean, another thing that has struck me about this winter is that it has felt like a high number of days with rainfall, and my perception of that is actually, I actually went and looked at the frequency. I'm drawing on sort of your analysis here, your figures that you produce, Mike. And, a normal winter might see on the order of like 25 days, and we're sort of right there, 27 in Tucson, 27 in Phoenix. So I guess like I'm answering my own question here. It's like my perception is that there's been a large number of a high frequency of days with rainfall, but it's sort of average.
Yeah, there's high variability in that number. Like it's pretty uneven, right, from year to year. And so I would expect if you composited out some of the El Nino years that they're gonna give you most of that kind of towards the mean to the upper amount of that. And I expect if we're just talking right now on March 29th about this upcoming storm event. What's interesting about the last three events have actually had fairly slow moving low pressure systems sweep through the southwest. And so that can lead to multiple days of rain, which is unusual for us, right? And also the weeds tell the story across the southwest. To grow weeds like we're doing in these epic proportions, you need to maintain soil moisture. And the way you do that is you stack up event upon event. And as the sun's been getting higher as we get into spring now, you'd expect that soil to dry out and stuff to kind of die back, and it's not, because we're getting these sustained events a week later, a week later. This is going to be the third Sunday in a row that we're going to probably have precipitation, which again, we don't we don't typically map out our or plan out our weekends to have multiple Sundays where you're going to get precipitation.
Yeah, I went out hiking actually 3 weekends in a row. I haven't been in the superstitions in years, and I went 3 weekends in a row to the superstitions. Fabulous place, actually, both from the west side and the east side. Anyway, very verdant out there, like green everywhere. So it is, yeah, that tells a story too. The other part, Mike, of the winter that I alluded to was the sort of slower onset. I mean, if you looking at Tucson, for example, we were trending below average up until about mid-January, and then it flipped. And it was pretty dry, through October and November. And oftentimes when you have that kind of situation, I mean, you really need the second half of the year to pick up for it to even get back to average. And we flipped the script. So it's been a really sort of late loaded winter, it seems like, to me at least. I don't know if you have any thoughts on that.
Yeah, this may be apocryphal at this point, but I remember reading a paper, or maybe we just said this out loud for many years. I do think this traces back to some work that maybe Kelly Redmond did in the 90s, or Dan Cahan on, it was kind of some of the first Western US El Nino, La Nina composite studies. And there's some evidence, at least it was at that time, that January, February, March are prime time for precip with El Nino events when you look at the Southwest. I'm not totally sure what the dynamics are of that, but if you look at some of that precipitation composites, December, January, February is often what we're kind of using as meteorological winter, which I think makes sense. And you certainly start to see the El Nino effects on the atmospheric circulation patterns getting into December, but it's not typically till January, February, and we're even seeing it now, even as the El Nino is waning, that the atmospheric circulation patterns have a lingering effect and continue to give you that. So it wasn't surprising to me that we didn't see stuff totally ramp up. I think we got through December, and I was expecting by the end of December we'd start to see stuff, and we did. In January was a little bit slow at the beginning, but it did pick up by the end of the month, and then by the end of January and through February, and then I expected stuff to wane quickly in March, and it didn't. We've actually had a continuation of these storm events continue to come along, and it's actually been a couple of different things if you've watched any of the forecast discussions, but it's been this lingering El Nino response, which I think has enhanced the storm track, the southerly storm track with the subtropical jet across the Pacific. But the Madden-Julian oscillation, our old friend MJO, has gotten in on the action and has helped enhance the storm activity, and is continuing to through the end of March now.
So we're going to get into ENSO, but that raises a question for me, because one of the questions that we're going to try to unpack is like, what was El Nino like and what was not El Nino like? And, the precipitation pattern, has some signatures of El Nino, but what you're saying here though is like, well, that Madden-Julian oscillation, played a role. And yeah, if we don't think about Madden-Julian oscillation and just think about El Nino, like, and lump in the impact of the Madden-Julian oscillation, like we're including that in El Nino. So it's just like, it's just like
I mean, it's never one thing, right? I mean, I think that's always been kind of the thing we struggled with, and the way you try to communicate seasonal outlooks and those kinds of things is that tilts the odds. There's these ideas of typical patterns that you'd expect to see, and we lean on those a little bit, but it's going to be this like gestalt, or this combination, this mashup of this big El Nino response, as well as weather. The internal variability of the system is always going to come in there, and other things are going to come into play. throughout the season. So that's, I think always why you'll get something that if you squint at it, it probably looks right. But if you get down to like real specific places, it may not totally shake out.
All right. Let me take us through the snowpack, unless you want to say anything more about the dynamics and the winter thus far.
No, man, I'm still trying to understand them all, right? I mean, it's always like a work in progress to wrap our heads around like, well, what exactly happened with the weather pattern throughout the winter?
Well, let me ask this before moving on. In terms of like the pressure levels and we always talk about the ridges and troughs, like was March, in terms of rain and snow, there was this kind of persistent parade of storms into our region that sort of continued from, let's say, mid-January on, right? Like, but was there anything different about March in terms of the larger scale atmospheric conditions from, let's say, January and February? Or did it have a similar kind of flavor?
It had a similar kind of flavor. I think what stands out to me is that we start to see the storm track lift north, by March, right? So
driven by the sun.
Yeah, I mean, it's sort of a retraction, right? Is that storm track will bottom. So everything is lagged, right? So we hit, we hit the shortest days of the year in the Northern Hemisphere in December. So we get into, and that's, meteorological winter, December, January, February. The January, February is the lag response to having that, bottoming out of the sun's energy in the Northern Hemisphere. And, we're at a lower latitude, so we're going to start to see the sun creep up higher. And so that storm track is going to start to rebound through the spring. And, during these El Nino years, and I'm positive this is part of it. It's not the full explanation of this kind of sustaining storm track in here, but it has been part of the energy and part of the pattern that has allowed these low pressure systems to continue to reach so far south. And when they reach far south, there's a ton of atmospheric moisture out in the Eastern Pacific that isn't always there. Like if it was a La Nina winter, it's much harder to reach into some of that subtropical moisture. There's just a lot of it around, and so it's easier to draw it back up into the Southwest when these low pressure systems can reach this far south. What we're going to start to see, though, is that the subsequent storms, they'll look pretty deep, but they'll just be half a state further north. And just that little bit of a lift can be, you can miss the whole stream of subtropical moisture across the Pacific. And it'll rain in Northern California with that storm and maybe through the Intermountain West. And we're just windy, right? And that's what we're staring at for the next couple of months, I expect, unless there's a real lagging kind of lingering effect of this El Nino, but I don't think that'll be the case since we're transitioning so quickly into La Nina now.
But part of that transition, part of the movement north, right, is a function of the sun angle, and we're now moving into, right? We're now moving into the summer conditions.
Yeah, it's all about solar energy, right? It's driving the whole system, right? And so the Earth system is super complex with large expanses of ocean bodies, and then there's snow on some of the land surfaces and not. And then in the Northern Hemisphere, there's all this weird assemblage of them. And so there's all these energy imbalances that are constantly forming with the sun's rays hitting the surface, creating pressure imbalances. And so there's always this trying to resolve all of those pressure imbalances. And then with El Nino and La Nina, you move those large heating anomalies. So there's extra energy in different parts of the ocean. And that can lead to these sort of persistent, lingering responses that the Earth is trying to resolve, over time with these pressure patterns and these wave patterns and the weather patterns that emerge with all of this.
All right. So you might have already said this, but put a finer point on this for me. So there's a kind of I'm trying to do the thought experiment of like, if we had a month where we might see, if we had a April or a late March to mid-April wet period, there would be some tug of war going on with, like, on the one hand, the warming, the solar angle increasing, and it's sort of like tugging at the position of these storms, trying to bring them further north. But then there would be other sets of conditions that would work in the opposite direction to try to tug the storm tracks further south? What would be tugging further south? What would the conditions need to be that would where they would actually win out from this persistent and continuous march of warming, driven by, these astronomical changes?
Yeah. So think of that storm track lifting north as an on average over time thing, right? So it's this progression over weeks. And so as the progression over weeks, you're going to see the mean position of the storm track lift north. It's just the climatological resolution of that. In any given year, you can have weird stuff that happens upstream. And so if we're thinking upstream from us, it's going to be across the Pacific Ocean. If you have any, tropical, you're not going to have tropical storms this time of the year, but any kind of things along the equator, like bursts of convection and where they are in those kinds of positions, can influence the jet stream wave pattern across the Pacific. And the strength of those waves, and if they're sort of, standing waves, or, and I'm thinking waves in the jet stream now, as they move downstream.
North-south positioning.
Yep. North-south positioning, right? And so that wave train, we call those Rossby waves. That wave train, depending on where it moves over you, sometimes they can move quickly and they'll resolve themselves. They'll kind of relax down. If they do that, you may not have big sensible weather. But if you have, large wave train moving across and it crosses across the Southwest, and so say we, in that wave train, maybe a large low pressure system. So remember that wave it's rising very, very far north in the ridge position. And so say that's happening over the East Pacific, and then it's crashing south towards us. And so that whole movement of the jet stream is going to help reorganize the air masses at the surface and can actually pull a lot of cold air down. And pulling that cold air down, it's going to create pressure differential. It's going to cause a low pressure system to form. If there's moisture nearby, that low pressure system can draw the subtropical moisture into the Southwest. And so you have not only the cold air, the pressure differential, the jet stream driving the dynamics to help sustain that low pressure system, but you're going to have the moisture to create precipitation. And so you can get a snowstorm, in Arizona in April, right? And so, and that's under a real high sun. And so you think about this is a really clever and efficient way of evening out all of these temperature and pressure imbalances, because you're dragging cold air south into a high sun. And so it's going to quickly warm up and resolve itself. It's going to modify the air mass. And so as it moves to the east, it's a different air mass, right? And so that's kind of the cool thing. It's like an engine to kind of exhaust energy that way.
Geointelligence.
Isn't it cool? I mean, it's so cool. I mean, we talk about it kind of anthropomorphically, like it's doing it that way, but it's physics. Physics and thermodynamics, right?
Fascinating. Okay, so you mentioned.
Yeah, I mean, if you, well, I'll just say real quick here too. That's what always kind of amazes me when it's a chilly day in the spring under a high sun. You can just feel how much work the sun is doing on that air mass, right? Like it is not going to stay cold for very long because it is getting worked on heavily.
Okay, so you mentioned these upstream, i.e. to our west, events can sort of perturb the sort of atmosphere in ways that give us weather when we otherwise might be, steadily marching toward warmer, drier conditions, which, is on our horizon, over the next couple months. One of those things you mentioned was sort of like in the tropics, like this burst of convection. And I just want to pull it back to what you mentioned before. I mean, that's like a Madden-Julian oscillation.
Yeah. Yep.
Like in these Madden-Julian oscillations, which honestly is like, I never quite understand. I mean, I get it conceptually. I don't understand why they form, but they're areas of high convection that sort of begin in the, close to India. And then they wander, eastward across the globe, and you can actually see them. If you're looking at the right kinds of variables and data, you can see them sort of traverse the globe, and they do so in, over like a period of 60 days. And so they fire up periodically in that time, and then when that sort of area of convection is in different locations as it's traversing, it's doing different things to the northern and southern hemisphere, jet streams, let's say, and so they tend to influence, like there is an expression of, in terms of precipitation and temperature in the Southwest, actually across the US, when the Madden-Julian, the locus of that precipitation or convection from the Madden-Julian oscillation is positioned in different areas. And I actually never remember where has to be to influence us, but
it's super not straightforward too, right? Because it's like it's so interesting because there are clusters of thunderstorms at the equator that can propagate into the wind. And that's what makes it so interesting, is that it creates a convergence that causes new storms to form in the wind, and it just propagates itself upstream. And they're big enough rising areas is that they can influence the Walker circulation, not all that dissimilarly from El Nino or La Nina. And so you can have these things where El Nino and the MJO or La Nina and MJO can constructively or destructively interfere with each other. And so you can get an enhancement or suppression of the kind of typical patterns, which is why El Ninos and La Ninas are never sort of a pure, clean signal, is that there's all these other sort of competing dynamics that can emerge within a season.
Yeah, and interestingly, or at least I find it interesting, El Nino and La Nina is a sort of climatological feature. Maybe I shouldn't say climatological feature, but it's the feature that provides the most insight on seasonal weather variability. In terms of prediction. It's not a lot, but it adds some value there, right? But at the subseasonal level, so thinking in the sort of 10-day to 4 weeks period, we call this, I'm using we as in the royal we call this subseasonal. And subseasonal forecasting really tries to leverage the MJO. It's, I think, the leading mode of variability for subseasonal kind of variability. And as we think about what can we understand weather in, say, day 10 to day 30, it's the MJO becomes an important variable there. And also, interestingly, weather forecasts, right? Like the sort of leading edge of weather forecasting in terms of predictability sort of ends at day 10. So it's really accurate, again, depending on where you are and what variable you're thinking about, but the accuracy is sort of high, like hours to a day, and sort of steadily declines to having sort of zero added value, like beyond day 10.
Totally. Yeah. I mean, and you just, you kind of map that out really cool in the sense of like El Nino, La Nina. It's all about persistence, right? It's that El Nino, La Nina are extremely slowly varying, at least in weather timescales, right? They emerge in, a couple of months, they persist for a series of months, and then they decline. And that the change in that where the heat is a persistent feature that's going to persistently tweak the atmosphere. So you can get some understanding that the weather might reorganize around that. And then MJO is you hope that it persists in a predictable way, like that once it emerges in one spot of the globe, it does tend to, move it can move around the globe in 60 to 90 days, but it's like those forecasts are really hard too, because sometimes MJO will like totally clunk out after 30 days and then reemerge another time. And so even those forecasts do rely on the expectation that MJO is going to move somewhere and do it in a meaningful way.
All right, fantastic. Let's move on to snowpack. And it's not surprising because the snowpack largely correlates with the precipitation. We already went over the precipitation pattern, and so what I'm about to say now is follows from that, and that is it's a pretty good snowpack picture across the West up until you get up to sort of Washington, northern Idaho, and Montana. It's very similar to the precipitation. I'm looking at now, though, when I talk about snowpack, like I'm focusing now on just the sort of high elevation monitoring station. So this is from the National Resources Conservation Services, and so these are snow monitoring sites that are at high elevation to pick up on the snow. And so you can either look at these in terms of individual stations, or you can look at them in terms of basins. And so thinking about the basins, yeah, like, you know, the upper Colorado River headwaters is about 106% of average. This is all in sort of the Colorado River Basin. The White and the Yampa is about 110, so we're in Colorado still. You know, the Dirty Devil, one of my favorite names, about 25% of average. Let's see. Let's go over to the Rio Grande. The Rio Grande headwaters, about 108% of average. The upper Rio Grande, so south of the headwater, is 133% of average. Anyway, the snowpack conditions in the Colorado River and the Rio Grande River across much of the West, south of sort of the upper tier of the U.S. is in a good picture. Is in a good state, I would say. Again, we're sort of peak snowpack conditions. There's going to be, I don't know, Mike, about this storm that is on the horizon. I actually didn't check to see how regional it is, but I'm envisioning that it's going to probably put some snow into the Colorado River drainage in some way. So the picture will get a little bit better up there even. So
yeah, it does look good for that.
Okay. You know, I mentioned before, so California. Yeah, so California, so the Northern Sierra is right at about average. So this is sort of the Mount Shasta area, Tahoe, and that's in that area. Central Sierras, about 80% of average, and Southern Sierras, about 80% of average. So again, these have climbed back to respectable conditions from where they started, from a really dry start, which we talked about before. What else do I want to say about snowpack conditions? Maybe a final point here is the really good picture is in part because of that persistence of precipitation that we've talked about. There was a dip about a month ago, and snowpack started to decline, but replenished itself through a series of storms. So the fact that we've had a lingering and consistent rainfall and storms into the areas is one of the reasons why we see numbers that are above average to much above average. So, for example, let me see. I have a picture of March. Okay, so in March, snowpack in March across the Colorado River Basin has been around 150% of average. So that's pretty fantastic. And similarly in the Rio Grande. February, you know, it was a continuation. February was actually even more than that. Close to, above 150, some in close to 200% of average. And January had above average too, a little bit less. And previous to that, it was dry, as we've noted to before. So I think the current conditions right now are in part a reflection of this persistence of precipitation, the storm track that we talked about before, keeping that snowpack at high conditions, despite the fact that there has been warm weather for much of the winter.
Yeah, and we haven't had any real strong ridges set up in March. That would be, you remember the whole idea of snow eaters? There's this idea of getting the ridges of high pressure across the West, high sun, higher sun than the middle of winter. And then that warm those warm, dry conditions would actually start to melt snowpack. So I think just what you're saying, Zack, is like keeping these periodic storms, it keeps the existing snowpack, probably protects it a little bit, and then adds to it.
All right. And so that follows, or what follows that is a little discussion, Mike. We don't get too much into this because the water supply situation on the Colorado River is always it's a Byzantine thing.
Yeah.
And but one of the points that we always try to make is that the stream flow forecasts are always less than what the snowpack conditions would suggest if you were thinking a one-to-one relationship.
Okay.
Yeah. So above average snowpack conditions in the Colorado, for example, does not translate into above average stream flows. In fact, stream flow right now, so the best guess for stream flow forecasts into Lake Powell would be about 91% of average. Okay, so this is usually I look at the stream flow forecasting gauge on the Colorado River at Glen Canyon Dam. That's sort of between the two reservoirs, like right outside of Page, in other words. Right south of Lake Powell, outside of Page, right, but upstream of Lake Mead. So that's 91% of average, which is good, I guess.
Yeah.
It's not last year. Last year was a real boon to the lake levels. I'll talk about that in a minute. But I mean, again, like, I don't know, it's about as good as, it's hard to expect a better winter across the upper Colorado River Basin than we got. Like, it's pretty good, like, as I just noted with the snowpack conditions. And again, the sort of stream flow forecast is for slightly below average, but below average, right?
Yeah.
All right. And then just moving over to the Rio Grande. Again, the Rio Grande has a similar picture, but a little bit more severe on the dry side. So the upper Rio Grande headwaters are forecast to have about, best estimate, so these are probability forecasts. So I'm looking at sort of the 50% exceedance level here. So best estimate, I would say, water in the in the Rio Grande's headwaters the forecast is for about 87% of average. As you move down sort of the Rio Chama, upper Rio Grande basin, as they call it, is about 68% of average. And then moving down to the lower Rio Grande, which is where the big reservoir Elephant Butte would be on the order of 45% of average. So stream flow forecasts, the big winter is not going to solve the water supply issue in the Southwest, obviously. I guess the only other thing that I want to note is when you look at the reservoirs, Lakes Mead and Powell in particular, normally the reservoirs sort of drain through the year, but receive a bump in like they start to fill up as obviously the snowpack melts. So March, April, May, June, maybe, there's an increase in the stream flow. So last year, Lake Powell filled on the order of 4 million acre feet, which is a lot. And that's one of the higher boosts we've seen in recent years. Some years you don't see any, right? There's just a steady decline from one year to the next in the water levels. It's complicated because Lakes Mead and Lake Powell are sort of managed jointly. So depending on water levels of Lake Powell or Lake Mead, flows from Powell to Mead will change, right? Like they've got all of these conditions set up that are related in part to how they're managing hydroelectric generation, in addition to water rights and whatnot. But nonetheless, in some dry years, you don't see any increase in water levels in these reservoirs. This year, let me see if I had it. I'm not sure I can find it. Oh, here we go. Yeah, so the expectation is that we'll see some bump, and there's a range depending on if streamflow forecasts end up being above what they're currently projected or below what they're currently projected. If they're forecasted for below, obviously we'll see a much smaller bump than if they're forecasted for above. I actually can't. I was hoping I could break these down into the same numbers that I just gave in terms of acre feet, and I can't because now they're in the site that I'm looking at is in elevation. But I think the point here is we can come back and talk a little bit more about how much the actual rivers filled up in terms of water volume. But at the very least, there's an expectation that the reservoirs will have a small increase, with the potential for there to be an increase on the average of probably what happened last year, which would be nice. That's a very low probability though, in terms of looking like it did last year, but there is still that chance.
There's a low probability of it having the same streamflow outcome.
Yes, sorry. Thank you for letting me clarify this.
Yeah.
So last year, in a really wet winter, there was a substantial bump when the reservoirs tend to fill. Okay.
Right.
This year, we can get a similar bump as we did last year, but basically what has to happen is we have to get a number of more storms coming in between now and the end of the water year, right? And so that's uncertain. This one will help that we've talked about, but also probably cooler conditions matter, right? Because then that would lead to less evaporation and less water loss. So that's why there's sort of uncertainty with these conditions. That's why they forecast them, because we don't know what the next 3 or 4 months will be like. We have much of our information already in the snowpack conditions themselves.
Yeah.
So,
right.
So we kind of know that, but there is still some uncertainty. And if we were to think about what's the pessimistic scenario, we would still get an increase in water elevation and volume from the snowpack that we've got. And the best guess scenario is the increase in volume will be a decent increase in volume. I don't know how else to say it, decent.
No, that makes sense.
Last year, but
yeah.
Not one of those years where there's just a small bump or not a bump at all.
Right.
Again, I think the point on the water supply, always the point is that there's a structural deficit. More goes out than comes in, and winters like last year sort of kick the can down the road, but the overall trend is fairly consistent, and the brass, the decision makers, the people that live in this area, we're ultimately thinking about how to live with or be more efficient with the water that we have, given that sort of we were given more than we really had.
Yeah, totally. Yeah, it's so interesting to think about what kind of winter do you actually need to get snowpack wise, consistency, timing to get us an above average streamflow forecast that then makes a demonstrable impact in the downstream reservoir operations. It's enormous, right? I mean, it is these winters are very, very few and far between.
Yeah, that's a really good question. And I don't have an answer for you. I can point people to somebody that I like to read when I'm doing some research on the Colorado River, and that's John Fleck. He's got this blog, Jay Fleck at Inkstain. He's always got some really interesting stuff. I was just looking at some graphics, but worth looking at him, following him. He's probably on Twitter. But yeah, I think it's probably on the order of last winter, and that doesn't happen very, very often.
No, in a La Nina winter that we didn't see coming. Right.
Yeah, like I don't think like this, let's say, above average winter is the kind of winter that we would need consecutively to get out of this problem. I think last winter is the kind of winter that you would need to sort of reverse the fortunes.
Yeah, a lot of them, right? Maybe even more than last winter, and you'd need them a couple years in a row.
Yeah, and last winter was historically, the snowpack conditions were historical, and like I'm looking at California, for example, in those basins, it was the third highest on record. And third highest across the Sierras. I don't have them handy for the Upper Colorado River Basin, but if that's any indication, that'll help. Okay, so moving on, Mike. All right, so we talked a little bit about this already, but I wanted to spend just a little bit of time thinking about what was El Nino like and what was not El Nino like about this winter. And so maybe it's just worth thinking about what an average El Nino looks like and then comparing this winter to that. So if you Google search, right, El Nino and images, right, you're going to get this classic image where you see map of the US, there is like a colored area across the northern US and Canada that says warmer. And then you get this sweeping arrow that says across the Southwest, sort of Southern California and below Arizona, New Mexico, and then kind of tilts a little bit north up around the East Coast. And it says like extended Pacific jet stream. And then there's wetter in the Southwest and wetter and colder in the across Texas and the South and Florida and slightly up into mid-Atlantic, if you will. Right? Like that's sort of the picture of an El Nino expression. Never really happens that way. I mean, but that's like the extrapolation of the average conditions when you lump together everything, all the statistics of El Nino conditions, right? And there's quite a bit of variability for that. Okay, and so then what we might think as an expected El Nino in terms of rainfall, the sort of canonical version of this is wet across California, across the southern half, really all of Arizona and New Mexico, but like a more intense expression of wetness across the southern half of Arizona. Dry northwestern Oregon and western Washington, and dry in Montana and Idaho. So Pacific Northwest dry, Southwest US and California wet, right? All right. Do you think that happened this year, Mike?
Sorta. Kinda. Sorta, kinda. Yeah.
Yeah, I mean, I think okay, yeah, so sorta, kinda, you're right. Okay, so here's what did happen. California with the exception of like the Sierras being around average, but everywhere else being above average. So that played out. Southern Arizona was wetter than average. That played out. Parts of New Mexico, particularly the western half of New Mexico, was above average. That played out. And then it was dry in Montana and northern Idaho and Wyoming, and that played out. And what didn't play out was basically the entirety of the West Coast was wet, from Washington down to the southern border of California and Mexico. So a fairly robust El Nino signature, I think, at least across the West. Not 100%, but like, I don't know, seems like pretty good forecast. What do you think?
Yeah, no, I totally do. So we're kind of riffing off of a very recent climate.gov ENSO blog post right now that was posted by Nat Johnson, actually yesterday, March 28th. And it does a really nice kind of deep dive into the expected patterns, Zach, that you just described and what we actually observed. And so, the expected canonical, we use that word a lot, the expected typical El Nino pattern is pretty even with the idea of wet conditions from Southern California all the way across the southern tier of the United States, continuously from Southern California, Arizona, New Mexico through Texas, Gulf Coast states, and then Florida. But in any given year, the storms, the way they set up and the way they stack up, when they put those patterns down, will give you a kind of, if you squint at it, you can certainly see that pattern, but there'll be dry spots and even much wetter spots than normal based on the internal variability of the whole season. So yeah, this one was kind of interesting. It's like El Nino plus because the entire West Coast got hammered with precipitation.
Yeah. Yeah. And like they did this analysis. I don't know if it's in that blog post, but I'm actually drawing from a presentation that Michelle Leheroux, is that how you pronounce her last name?
Mm-hmm.
And she's at NOAA's Climate Prediction Center, gave a couple, maybe last week, and they did correlation pattern. So they looked at the expected El Nino rainfall signature and then correlated it with the December through February pattern this year. And it's a pretty high match. One of the highest for El Ninos, not the highest, but it was a strong El Nino. And if you go back to the last strong El Nino, the 2015, 2016, the correlation match there was one of the lowest for El Ninos of this magnitude. So I don't know. It ended up in terms of the precipitation. And I should just say what I was talking about, the match was US wide, not just the Southwest. But yeah, it was a pretty good match to the expected situation. But what about, Mike, like the pressure patterns, like the atmospheric conditions? How did those sort of align? What's the canonical?
Yeah, the canonical, and I think we talked about this in maybe the previous two podcasts, but what you typically expect to see is if you have the El Nino pattern emerge with the warmer than average water temperatures in the Eastern Pacific, is that the convection changes across the equatorial Pacific from east to west, and it changes something called the Walker circulation, which I think we've talked about in the past. And this Walker circulation is going to have impacts on the northern hemisphere jet stream as well as the southern hemisphere. And so typically what we'll see when we have that reorganization of convection, Walker circulation, and then the jet stream response is that you typically get a stronger than average Aleutian low, which we talked about last month. And then sometimes and oftentimes an extension of the jet stream across the Pacific Ocean, including the subtropical jet. And so that's typically what will give. So you were just describing earlier, Zach, is that we talked about that kind of wet stripe across the southern tier states is typically strong El Nino events, is that you're going to have that whole winter storm track be further south and persistent across the southern tier states. And so if you can set that up and it's persistent, you're going to get above average precipitation patterns across that. So this year indeed did see the Aleutian low was stronger than average. It was, and again, we add all these up and average them together, you get this typical pattern. But in any given year, that low pressure system is in a little different spot. So this year, the Aleutian low certainly was stronger than average. It was a little bit deeper south and further east, often in the throughout the wintertime. And what that led to, or it was a reflection of the troughing that was coming across the western U.S., which did end up bringing storms from the Pacific Northwest all the way down the Southern California coast, and were the ones that traced and tracked in through the Southwest that gave us that kind of wet stripe from the southwest of Arizona all the way into northern New Mexico.
Those created the sort of atmospheric that people are probably.
Yeah, yep. And so I think this was, I'd have to look at this kind of like day by day, but I'm thinking back to like 2009, 2010 was a big, was not a big El Nino year. It was a moderate El Nino event that came on quickly after the summer of 2009. It came in the fall. Zach, you and I were working on that project with FEMA at that point, and it was a real punchy El Nino event. And if you look at Michelle's pattern correlation, it was a highly correlated precip pattern. So it had a real good like southern tier wet stripe across the southern U.S. And what I remember with that winter was that there was a period of time in January where the East Asian jet connected with the subtropical jet across the Pacific, and it was just like a fire hose. It shot storms, slingshot storms into the West Coast, and they carved right through Southern California, Arizona, New Mexico. And it was really, really intense storms, record snowfall in Flagstaff, and we got a lot of rain through that event, and then it retreated real quickly. So that's always kind of like when I think of like, oh yeah, good, that's what an El Nino can do, is like really funnel those storms in. This winter, the jet stream has been a bit wavier. So there's been kind of a wavier mid-latitude jet that would connect up with the subtropical jet occasionally, and then drag in the atmospheric river moisture up through that, and then it would move off to the east. And so it was a little bit different than that real like burly subtropical jet that like just points across the whole southern tier.
Right, but taking a step back, like we see an El Nino expression in this winter, in terms of the atmosphere.
We do, yeah, exactly. So this is as right of an El Nino expression as 2009, 2010, right?
Yeah, but I mean, strikingly, the pressure pattern, when you look at an expected El Nino, again, the Aleutian low, like a high pressure over Canada, like a low off the eastern seaboard, right? Like that's more or less what we saw. Like there's some subtle differences, maybe not subtle. There are some important differences. You already mentioned like the low is maybe what we experienced this winter is a little bit more toward the West Coast, eastward.
Yeah.
Than the canonical. The high, over Canada was more pronounced and that sort of thing. But like, I at least for me, answering the question of like, can we see El Nino in this winter? And I think it's fairly evident.
Definitely.
Okay. Anything else you want to say about that, Mike, before moving on to a final moment? We got to get you out of here in 5 minutes. So maybe we should just
another meeting.
Final moment. So we now turn our attention to, the protracted dry and hot season before the monsoon comes in. But I'm just curious, what are you eyeing for the spring? What will you be paying attention to?
I quickly pulled up. So it's Friday, March 29th at this point. And so on Fridays, this is kind of a weird thing to be excited about, but the Climate Prediction Center issues their week 3-4 forecasts every Friday, right? Yeah. And so it's like we're in the time zone where they come up kind of early in the day, right? So I'm always like, oh, it's interesting what you're going to see.
Are you refreshing?
So, yeah, totally, man. I was trying to see when it was going to pop up, and so it's interesting.
Well, it's going to have it above, right? Because of the storm on the horizon.
Well, this is for April 13th through the 26th. So the week 3-4 is
the week
is out.
3-4. Yeah.
Yeah. So it's outside the 6 to 10 day and 8 to 14. Every one of them, 6 to 10 day, all the way up to week 3-4, have above average tilt for the Southwest.
So this is the subseasonal forecasting that we were alluding to before, right?
Yeah.
So this, like, there's an MJO sort of influence here.
It could be. I didn't read the discussion yet, but I'm curious. It looks kind of El Nino-ish. It's got a basically, it's an above average tilt across the whole southern tier states. It's got us in just the very, very lowest category of lean, and it pops up over Texas, which has
maybe maybe April. Give us April a storm or two.
And the interesting thing here too, Zach, is that it has the entire, Four Corners states in equal chances for temperature. So we're used to actually seeing that like always be painted red with an above average temperature lean. It's actually got equal chances, so that doesn't mean it will be cool, but it's saying that there's not sure with this wet signal. This could be really interesting to see how snowpack, does it continue to evolve over the next couple of months? Does it actually, these if it's not blazingly hot, the snow eater events, does that protect it a little bit? I'm really curious to see how the next couple of weeks shake out. But can you imagine us getting into May and carving off one of the hot spring months and then just dealing with May and June?
It'd be fantastic. So let me just drop a few of the things that I'm going to eye, and then we can sign off. First thing, sort of globally, like I think the global temperature and where its position is, like relative, like right now it's trending at the warmest, and it has been, late last year as well too. And it's boosted by the residual El Niño, which can have lag effects up to 6 months. And so, media wise, like the global temperature is something that I'll continue to watch, and media wise, it's a big story. Right. And then more regionally, obviously, is what the monsoon setup will look like over the next couple months, and some of the things that we'll be looking at there, just to march forward from Mexico of precipitation and just the heat and maybe the more or less heat and the warming of the oceans and that sort of thing. So the monsoon setup, fire, when now we're in the fire risk, again, what you mentioned might tamp down that fire risk. We're probably in a less of a fire risk situation, at least for the higher elevations where there's the big fuels, than we have been. Maybe not last year, because last year was also a good winter, but it's, I think the fire season is something to pay attention to. And that's also influenced by how warm our spring will be. So those are a couple things that I'll be paying attention to.
Totally. And I already slacked you a forecast for the summer, and it's not looking good. So I'm already
what summer? Like, are we talking June, or are we talking like the monsoon?
June. This is the European Center's June, July, August outlook, and it looks like last summer.
Really?
Yeah. So
I don't put a lot of stock though into
I don't either.
I'm on the record as saying I don't think we can forecast the monsoon with any sort of.
It was just emotional. Like, I was just looking at it, kind of like, blah. But there's all sorts of interesting stuff underway. This transition to La Niña and the speed of it could have an impact on helping, with the monsoon setup. So there's a lot to talk about and a lot to pay attention to the next couple of months.
All right, fantastic, Mike. As always, thanks for the talk, and we'll come back in a month.
Thanks, Zack. Appreciate it.
All right, take care.
Readings in astrology. 1, 2, 3, 4. Astrology never meant that much to me. The woman I thought was just so, she now tells me we ain't compatible. She says, see, look right here on the paper, you should be loving your neighbor. Loving my neighbor's out of sight. But I'm your man, and I'm just trying to do right. But I can see there's some trouble coming right here with this funky woman. The love I thought she had for me, and I see is gone to some astrology. Well, baby, I can see your pain. You better wake up before it's too late. Straighten up and make up your mind, or you need a horoscope to find another love sign. Why, yeah. meant that much to me. The woman I thought was just so, she now tells me we ain't compatible. She say, see, look right here on the paper. You should be loving your neighbor. Loving my neighbors out of sight. But I'm your man, and I'm just trying to do right. That astrologer's joke